Hello dear students, how are you? Today's lesson is in math, recognizing and describing two-dimension shapes and solids. Book 7. This is the last time I take a subject from book 7. This is the last subject in book 7. From now on we shall take only subjects from book 8. So, objectives. What are two-dimension shapes and how you describe them, how you distinguish between them, which one is which. And then what are three-dimension shapes, which are called also solids, and how you distinguish between them. And then we shall make an exercise to see how this works all about. Or what are the two-dimension shapes? These are two-dimension shapes. They have length and width, all of them. We call them quadrilaterals because four-sided figures and four corners. All these shapes have four sides and four corners, but they have special names also: square, rectangle, parallelogram, rhombus, kite, and trapezium. And these are triangles, and we call them triangles because it comes from tri means three. That means they have three sides and three corners. Okay, they have special names also. Isosceles means that the triangle have two sides which are equal, but the third one are not. Equilateral, all three sides are equal. And scalene, all three sides are not equal in length. I mean, this is the length is different than this one, and the length here is different than this one. And right angle, a right angle triangle means a triangle that have one of his angles as 90 degree. So right angle means 90 degree. So you see this one here, this is 90 degrees. So this is a right angle triangle. These shapes all are two-dimensional shapes. So what happens if I tell you in a question, please, what is the name? Name the shape which have this feature and this and this and this. You have to know from the feature I give you which shape is meant by the question. Let us take this example. We start first, this is the argument, this is how you argument about it. You start with the sides first. We have these three shapes, okay? I shall start with the first argument with myself. In the question I am telling you that the four sides are parallel. So all four sides are parallel here. This is parallel to this one, this opposite to this one is parallel, also this one's the same, this one also, all are parallel. So I cannot distinguish between them. I don't know which one is which. So I have to go to the second argument and would say the four opposite sides are equal in length. Are they equal or not? I have to know that from the question. In the question I say to you, yes, this shape I want is the four sides of this shape are equal. Okay, are the four sides are equal? The two opposite sides are equal. Yes, but not all four of them are equal in length. So this is the wrong answer. So I have only a square and a rhombus. Why? Because all four sides are equal in length. This opposite side are equal in length, and this opposite side are equal in length, and this one is equal to this one. So all four sides are the same length. So how I distinguish between them? I go to the question. Of course I shall give you another information. I tell you all the four opposite angles are not, I repeat, are not 90 degree. So the opposite angles here, this one and this one, are 90 in the square. Also this one and this one are 90. So this one is the wrong choice, and I'm left up with the rhombus because the opposite angles are not 90. So the answer is a rhombus. We go again to these three shapes. We see how this works again. So again, in the question I tell you four sides are parallel. Again, they are all parallel. I don't know which one. Square, rectangle, and rhombus are all parallel. I go to the opposite side are equal. Four opposite sides are equal. Okay, again this one is the wrong answer because I have not all four sides are equal, only these two here. Then I go to the third argument about the angles, and this time in the question I am telling you four opposite angles equal to 90. This time my shape which I want is equal to 90. So I have the square, it's here, opposite sides are equal to 90. So this is the correct answer, and the rhombus I disqualify him, and the answer is going to be a square. So again we go to three-dimension shapes now, the solids. They are not very hard, so the same argument, not the same argument, but the same way how you distinguish between them. Also you have three arguments, but this time the argument is not length and angles. No, it have to do with faces, edges, and vertices. You have to know what are these things. But before that, let us know what are these solids. We have cuboid and we have cube. Sphere is a ball, this is not a circle, and a cylinder. And then we have a square base pyramid, a square base because we have a square in the base, okay, and a triangular base pyramid, and a cone, and a triangular prism. These are the shapes which are important, and how I distinguish between them in the question. I give you a question, how I know which one is which. You use also three arguments: faces, edges, and vertices. What are these things? Faces. How many faces have a sphere? Only one. How many faces have a cylinder? This one, and at the bottom and the base, and this one. So 3. So how many faces have a cuboid? 1, 2, 3, 4, 5, 6. And this is also 6. How many faces have a square base pyramid? 1, 2, 3, 4, 5. How many faces have this one? 1, 2, 3, 4. How many faces have a cone? 1 and only 2. 2. So you start with the face and the edge. What I mean by the edge? How many edge have a sphere? 0. How many edge have a cylinder? This one and this one. How many edge have square-based pyramid? 1, 2, 3, 4, 5, 6, 7, 8. This is how you count the edges. Okay, what about vertices? These are the vertices here. Do you see these green balls? This is a vertex, and this is a vertex, and this is a vertex, and this is a vertex. So it is 4 vertices. And this one, how many vertices in the cone? A vertices is this point here. This is one vertex. So you have only one vertex. How many vertices have a triangular prism? This one, 1, 2, 3, 4, 5, 6. 6 vertices. So our argument will be built up like this. We start with faces, edges, and vertices so that we distinguish between the solid shapes. Can we have an example for that? This is called vertex. This is one vertex, and these are called 4 vertices. Okay. Now let us take this example. We have the same shapes here. We start the faces. I say in the question the shape has more than 4 faces. Which one of these shapes have more than one face? More than 4 faces. This is one face. So this is not qualified, and also this is not qualified, and this is not qualified, because this have 3 faces, this have 1, 2, 3, 4 faces, but in the question he said to me more than 4 faces, and this is one face, so I have only these 3 solids. I have to distinguish between them. I go to the second argument, the edges. The shape has more than 8 edges. I tell you the question, my shape have 8 edges. So I count the edges, and I see this is not one of them because it have 1, 2, 3, 4, 5, 6, 7, 8. But he said to me more than 8. So which one is qualified now? This one and this one. Okay, let us see. We go to the vertices, and he said to me the shape has more than 6 vertices. Okay, I count them. 1, 2, 3, 4, 5, 6. This is 6, not more than 6. So this is not qualified, and I'm left up with the cuboid. The correct answer is the cuboid. Okay, correct answer is the cuboid because he have more than 6 vertices. Let us see that. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 vertices. So it's more than 6. So the correct answer is the cuboid. Now let us go to exercise 8.1. Let us see. I chose a question number 5. I chose question number 5 from this exercise. Write down the name of the solid shape that is being described. The question will come something like that. When you cut me in half, the number of faces on one of my halves is double the number of faces that I started with. So I think we have a sphere. Okay, it's only one face. If you cut them in half, the faces in one half is double as this one. This is a face here, and this is a face, 2 faces. So the sphere is the answer. If you cut it in, the sphere before cutting is one face, and you cut it in half, it have 2 faces. Only one of them. Altogether is 4 faces. 1, 2, 3, 4. But he say to you, in one of my halves. This is one of his halves, and it have 2 faces. So a sphere is the shape that he means. Thank you very much. Go to the classrooms, and you shall find the homework there that I gave you concerning this lesson. Thank you, and have a nice day.